Hello, I'm Bryony Worthington and this is Cleaning Up. And today, on one of the hottest days of the year, I'm here interviewing James Macnaghten, founder and CEO of Caldera, a UK manufacturer of innovative clean heat batteries. They take everyday metals and iron ore and make batteries that can store all of that clean excess electricity, turning it into useful steam for manufacturing. Please join me in welcoming James Macnaghten to Cleaning Up. James, thank you so much for welcoming me here to Caldera. I wanted to start by just asking the question we always start with, which is, could you introduce yourself, please, in your own words?
Bryony, thank you very much. I'm James Macnaghten. I'm CEO of a startup called Caldera, and we are hoping to, we're basically working on a solution to tackle industrial heat, particularly for factories that make pretty much everything you eat, drink, pharmaceuticals, your cardboard boxes. And just as a bit of I studied as an engineer. I have run a number of businesses over my life. I got into heat almost 18 years ago. And I was running a company called Electrification, where we were looking to convert electricity to heat and back to electricity. And when we started, lithium-ion batteries were $1,000 a kilowatt hour. I think when we finished, they were $200. And yes, we weren't cheap enough. And nowadays, I should say they're $40 a kilowatt hour, to me for the pack. So it's one thing I learned along the way is never underestimate how fast technology moves. But also along the way, I realized that actually storing heat was really important. And Caldera is built around that.
Let's talk about then what Caldera is. So it's a heat battery, not to be confused with a lithium-ion battery. And its purpose is to do what? To take excess electricity?
Yes. So we're really clear. We take electricity in, we store it as heat, and we produce steam on demand for factories that run processes, brewing, distilling, sterilization, pasteurization, a whole range of these processes. We don't take heat in. So our view is we're moving to a world where there's large periods of excess generation. We need really affordable solutions to absorb it because you don't get huge numbers of hours. And so you need to absorb it at the right time. And then we produce steam. And we both do electricity in and steam out because moving heat around as steam is the cheapest way to do it. And electricity is actually the cheapest way of moving energy around pretty much, period. And we wanted a standardized product that you could plug in anywhere in the world.
And just so people can conceptualize this, are you essentially building kind of thermos flasks? I mean, something that can store heat for a long time that you can then release it when you need it.
If we are building a thermos flask, one of the distinguishing bits around our technology is we use vacuum insulation that we developed. And to give you an idea, our store is roughly 10 meters high, 3 meters in diameter. And the cover that goes on it is basically a giant upside down coffee cup, like you have your insulated coffee cup, and we turn the cup and we drop it on and it covers the whole store. And then when we want to, if we ever need to look inside it or do anything, we can just lift it back off. And in terms of the store itself, it's heavy, weighs about 120 tons, which isn't surprising because we use stuff, we store the heat.
So what is in it? So it's definitely not hot tea inside this. So what is inside it? What's the medium that's storing this heat?
So we make composite blocks from recycled aluminium, and we originally started with rock. We've moved over to iron ore pellets because they just give a better energy density. And we create I describe it as a triangular wedge. It's a block, but it weighs about 1.8 tons, and it's a single piece. So it's probably the easiest way to describe it is like high temperature conductive concrete. Mm-hmm. The aluminium is 100 times more conductive than the pellets. And having the conductivity means we can do two things that most people can't do. We can put electric elements directly into the material and heat it. And that just keeps the cost down because electric heating elements, industrial versions of what you have in your oven at home, they're not expensive. And we can also get the heat out directly from the block by putting a steel coil within it. So we basically make these blocks and then we stack them up. So you have 6 of these wedges on a layer, and we put 8 layers together, and we have 48 of them. And now you have a tall thermal store.
And just so people can imagine then, the store, what kind of heat output are you getting? How many, if we were at a factory that's producing, I don't know, a food manufacturer, is it 3 of these? Is it 10 of these? What's the output in terms?
So I would say 2 to 10. One would be a relatively small factory, or they might not have a lot of processes that need steam. So I suppose to sort of set the scene, normally you've got old factories, big boiler house, 2, 3, 4, 5 boilers, always have a couple of them on. They've got one spare or one on sort of what's called hot standby, and they go 24 hours a day, often 7 days a week, using huge amounts of energy. They tend to produce steam, and steam's really an interesting material for cooking, because if you control the boiler produces steam at, let's say, what's called 10 bar, 10 times atmospheric pressure, and it's about 185 degrees Celsius. And if you let it go from steam to water at that temperature, you get a huge amount of heat transfer. That's why you can get burnt so badly from steam. But also, if you change the pressure, you can control exactly the temperature at which the steam goes to water. So if you want a food process where you don't want to damage the proteins or the structure of it, and you want it to happen at exactly 110 or 120, you can do this by controlling the pressure, and you can do this all around the factory. So it generally the boilers start at, say, 10 bar, and then different processes use it at lower temperatures. And you have a big pipe that goes the whole way around the factory that's fed continuously, and each process can drop the pressure and do the heat transfer at the temperature it wants to. Historically, everyone went, well, I've got a steam boiler, and probably they were coal-powered in the good old days. Yeah. And they're like, well, let's do the heating from it as well. So you'd have a lot of processes which are now completely addressable by heat pumps, where they'd be just doing hot water. So we tend to be going in now to factories where I would say people are recognizing this, and all the lower temperature processes are dealt with by potentially heat pumps. But there's still a number of processes like sterilization where it's just very difficult to retrofit a heat pump into the factory, or the heat is in the wrong place to where you want it. And so that's our sort of core market. And what we do is we help them decarbonize. We go to factories, and the steam loads, I would sort of go roughly 60% is static, and the remaining sort of 60 to 100 is very, very spiky. It's a batch processes, valves open, they go up and down, and they really vary significantly. And they were looking at going, well, we put the heat pumps in to cover the base load, but the heat pumps, you don't really want to be following spiky demand. Now,
so you're an additional service.
We're sort of going in there to do the spiky demand, and the nice thing is we can do very big spikes, and we see this as sort of, I call it power management, which is we manage the electricity in, so it's at the time the factory can, it's got spare capacity, and we manage the steam out to match what the customer needs for their current processes, and at the same time you can let the heat pump, if they fitted them, run steadily underneath at
You're kind of like an adapter plug, really, aren't you, for heat? Yeah.
We are. We're the ones, but it's the sort of, and the trouble is, if you went to do it with an electric boiler, which is perfectly reasonable, is you need a grid capacity now for that full size, but you're only using it for 5 minutes at a time, and everywhere in the world we go, the grid is congested. Every case we've run against an e-boiler, we win, because you save them on the capacity, which is expensive, and we also then can hit the spikes, so you don't need as much electrical infrastructure to effectively do the ups and the downs, or you can buy your electricity when it's cheaper. Yeah. So those are really important.
Let's just be clear then. So there's different grades of heat. So like low grade heat that we'd be using in our home, which is just running a radiator or keeping the shower hot. That's up to 60 degrees?
60, yeah.
And so then you've got that kind of medium grade heat, which is your category. Is it sort of...
Maybe a little bit hotter. I mean, medium grade heat, I think from an industrial perspective is up to 500 Celsius. Yeah. The bit we're interested in is up to 200. And basically for industrial, it's, so the sort of big numbers are 25% of all energy is industrial process heat. Some of it's very high temperature, so steel making, cement making. But of that 25, 10 of the 25 is below 200 Celsius. And we go, it's really addressable. It's like, I get in trouble, but I go, I don't know why everyone's obsessing about high temperature. They go, it's like, we've got to tackle all these really hard problems. And I'm like, but we haven't done the easy ones.
Yeah, exactly.
And it's like, we shouldn't be spending our effort on things to do 1500 Celsius when we haven't done everything below 200.
I would love to go and see some of the people you've got here at the factory, and we'll hopefully get a chance to see some of the processes.
Lovely. Let's go and have a look around.
The Caldera factory is located just outside Southampton, and it's where workers in shiny silver heat suits melt down old aluminium blocks to create the superconductive core of Caldera's heat batteries. Inside the factory, James showed me around the foundries where they melt down the aluminium. So, James, tell me, where are we?
Right, well, right in the centre of our factory. So over to my side here, you've got 3 big ovens, which is where we preheat all the moulds and the pellets. And we've got 2 foundries. We've got the old one on the right and the new one on the left. New one's all electric, which is what we use. And you can see we've got quite a lot of recycled aluminium bars around for when we're making blocks. And then this half of the factory, we do all of the coiling of the pipes, the welding, the assembly, and we do the demoulding from when the block is made and we can pull it out. So it's roughly 50-50 between sort of, I'd say, manufacturing and then the production bit, which is the ovens and the foundry.
Outside the factory, Caldera has built its test batteries, tall cylinders that act like a big vacuum flask. On the outside, they're almost cool to the touch, but inside, they're heated to several hundred degrees, heat that's ready to be turned into steam for factories and food manufacturers. So what are we looking at here, James?
It's a bit like 3 bears. This is Mummy Bear.
Yeah.
The small ones, we started off a Baby Bear, and this is Daddy Bear over on the far side, which is 5 megawatt. So this is 5 megawatt hours. This one is for 4, and we've pretty much standardised now on the 5 because it just fitted much better with what customers need.
And so if that's at top temperature, how long does it take for that to be drawn down? Like, when is it empty?
If we left it, months.
It would be staying heat hot because of the vacuum.
Because of the vacuum.
If you're drawing off the steam, I guess it depends how much steam you're drawing.
4 hours, with the latest version we're coming out, we should be able to do in 2 hours.
Oh, so you can take that much heat out that fast if you need to.
So for us, it's about steam loads, they have huge spikes for 5 minutes and then nothing. So it's about how much power can you get out rapidly.
Yeah.
We're not, I would say, what I said earlier, we're not in the business of doing 10 or 15 hours of storage. We're really about doing lots and lots in and lots out, and they can be at the same time as well. Finally, back inside the factory, the Caldera team dressed me up in a silver heat suit to protect me from the 750-degree oven. And then I poured my own miniature version of the superconductive core of their heat batteries, a combination of iron ore pellets and recycled aluminium that weighed an absolute ton. Well, that was me pouring a sample block of the composite material that stores the heat, which is basically waste aluminium that's been melted down, combined with some iron ore pellets, which basically bulk it out. But yeah, it's quite a thing to be inside this beautiful bespoke outfit, helping with a little bit of industrial process on the hottest day of the year. Thanks for letting me do that. You're very welcome. And it's always quite fun to handle molten aluminium. So it's been really great to show you the factory. So we've been around the foundry, we've been around the ovens, we've been out and seen the demonstrator at the back. So, and you've had a chance to see how the vacuum insulation works and steam production. So we've done the whole thing. And then obviously it's lovely to be able to dress you up in shiny silver and let you make your own little block to take home.
I did feel like a cross between Count Binface and a kind of alien, but yeah. Anyway.
Well, you did very well.
The thing I was making there, that felt quite small. So that's not the actual components. That was just a test.
No, it's actually, so it's basically bread bin size, a bread bin. It's a loaf size that we let you make. But it's still surprisingly heavy. So I'm sorry that you're going to have to take it home with you on the train. But it's like the full block is 1.8 tons and you need heavy cranes to lift it.
But it's pieced together through, or no, you
cast
it in one piece.
So it's a single piece that we cast and it's conductive because the aluminium is like the superhighway that runs throughout the entire block. And that's the secret. So aluminium is, it's so much more conductive than any other material, but it's not that expensive when you bulk it out with the pellets because they broadly have the same heat storage ability, but the pellets are really cheap.
And there's a lot of aluminium in circulation that you can recycle.
There's a lot of aluminium in circulation.
All those ice engines that we're not going to need anymore.
There's a huge number of ice engines, but also we're very unfussy about the grade. We will take any grade of scrap aluminium.
Maybe we could just talk a little bit about Caldera, the company. So where are you in your journey? Like, you're still a privately held company? Have you had investment from VC? Is it you all backing off your own balance sheet?
So we've had a bit of a long journey, nice and agile, just like typical UK startup.
Done a few pivots.
We've done a few pivots along the way. We've raised quite a lot of money. So we have about 2,500 private investors. We've been out on Crowdcube 3 times to raise money. Last year, we took a large investment from a big DAC 40 listed German company called GEA, who are very well aligned with us. They do high temperature heat pumps, and they basically work in every sector that we're interested in.
How many people are working here, and where are you? How long have you been going?
So, company employs 28 people. We've been going since 2017, and we were very small for quite a long time. And we also made a pivot in about 2022 when we switched from building units for homes for building units for factories. So originally we started making a small home unit that was 100 kilowatt hours. And the idea was we'd sell homes, big homes, with oil that had cast iron radiators and needed 70-degree heat. So not particularly amenable for heat pumps. And we were just getting going, and we were starting to do some trial deployments, and then Russia invaded Ukraine, and oil went from being probably the more expensive fuel to being the cheapest fuel, and overnight electricity suddenly became very hard to get hold of. So we made a decision at the time. We'd wanted to go larger, and it was quite helpful. There was a particularly good government grant program that came out. So we basically did a big pivot between then and 23 when we basically switched out of domestic, and we said we're going to be larger industrial. So, and I'll be honest, we had a lot of government support, so very appreciated and helpful. But we've slowly grown the company steadily, and then we had a big investment from a large German multinational last year, and that allowed us to jump from sort of 18, 19 up to 28 people, and it doesn't feel like it's enough.
But how many units are you producing?
So we're just early stage, we're starting. We've got, you've seen the one out the back, it's the second one we've built, aiming to sign, very much fingers crossed, first contract. We're hoping to hear this week, but it will sign within the next 2 months. And that'll be on a site in the UK with a multinational if it goes to plan. So that's where I'd like to be. I would say we have both inquiries coming in and from UK and Europe, but it's a relatively mature market we go into. So the normal sales process, it's about a 2-year cycle. So I would say there's quite a lot that's coming in that will happen, if not next year, the year after. But it's really exciting.
At the moment then, you showed me around, but these are fairly bespoke. You have to build them here. Like, it's not a factory that's churning out units by the hundreds. Is that the vision though? It
is totally the vision, but we're also working on the product. So it is a very churnable outable, so one of the reasons we distinguish ourselves is we're looking to have so the vacuum insulation gives us a big advantage, which is we get low losses at a relatively small size. So everything's transportable, and we set the diameter on what you can road transport without a police escort. So it's 3 meters in diameter, 10 meters long. We can transport it anywhere in Europe really easily. And because it behaves like a big store, but it's small, we can build them in a modular fashion. Intention is within a year, we want to be putting the base down, assembling the store, having the cover on in a day. I would say most of our competitors tend to have to build on site, and it's something we're really wanting to move away from because I think it makes it much harder to scale.
Yeah.
So our intention is to have something that we can send out and we deploy really quickly. And I think we're quite different in that respect because a lot of them tend to be buildings that are quite large and take
Well, we just had a recent episode actually with Professor Ning Li from Xiamen University where we were diving into what's made China so successful about this, and it's modularization, right? It's the work out how to make things rapidly, iterate, and get the production going. And if we can do that for this technology, then, you obviously then need a factory, and you'll move from here to somewhere else. Is that still planned to be in the UK?
But the aim is we actually have in our ideal world, we work quite closely with the foundry that sends us the recycled aluminium. What we'd love to do is locate very close to them. So rather than them melting the scrap and pouring it into ingots, which we remelt here,
that
we
doesn't
could
sound
take the
efficient.
molten, we could take the molten aluminium directly, and that's the sort of way we'd like to go. So they literally melt it, pass it over you can get these big containers that you can sort of move around quite easily with molten aluminium in, pass it to us, and we can make.
And where are they? Are they locally?
They're in Staffordshire.
Okay.
They're in Staffordshire. We work, as I said, very nicely with them. And we have had discussions along these lines. So that's the way you scale very quickly, because we don't want to be melting scrap aluminium. There's a lot of processes in place to handle it. It can have a lot of chemicals, contamination that you need to manage. We just want to take the aluminium. That is a way you could scale very, very quickly. So we could go from this factory here, where we have capacity for 600 to 800 blocks a year. You could easily get to 6,000 to 10,000 without spending a lot of capital, which is why it's a very nice route. The other bit about our system is that the cover, the base, the electrical controls, we don't make those, and we don't want to make them. Anybody that makes a steel tank, we can show how to make the cover. So from my side, it's just the internals is ours. And that's why it's also scalable, because we would ideally like to be making them wherever we're sending our equipment. What
is it, do you think, about your background that makes you take on this challenge? Like, you're obviously passionate about this, but are you a serial entrepreneur?
On this one, I just find it fascinating, and it's challenging. You have to bring lots of different disciplines together. It makes it kind of exciting. But I am a serial entrepreneur. So I studied engineering at Cambridge, and I dropped out my final year to start a boat hire business. And now I am Cambridge, the boats on the rivers, punts, as you remember from being there.
I was there last week.
I am Mr. Punt, I think. So I still own the business, and I employ over 200 people at the moment in this time of year to do tours. And it's a lovely little business, but I find I'm much better at start. I like this phase of the development. When the business becomes more mature, that's when it would be time for somebody else to step in. But
that's fascinating. So you had that insight there, because clearly punting in Cambridge is synonymous. Like, it's just, so you knew you've got that business sense, but really now you're using your engineering brain, aren't you? I don't know how much engineering there is in the punting business.
Well, enough, I introduced that they have these bigger boats that I introduced the wide boats. When
I got married, we had a punting tour, and we hired 2 of those 12-seaters, so we had 24 of us going down the Cam. So maybe they were yours.
They were never that. I was responsible for that.
So you invented the bigger ones?
They were only
because of the ROI. Was it a good?
It's much better. Yes, so one person pushing it, or one person taking the tour. We introduced those, and everyone slightly said, "Oh, it's not very traditional," but they've lasted the test of time.
They have. They're very useful.
But I think this space is quite fun, because it needs, you do need that ability to be quite flexible. I think you have to go after opportunities. They're not always apparent. You start off with a view about what your market is, and then you have conversations with customers, and you go, actually, it's slightly different. Yes, we can do that. One of my jobs, I always say, is to say yes and come back and go to the engineering team. I've committed us to do this. We're going to. Because you don't.
That's how you challenge the process.
But it's also how you learn. It's like, it's the idea that you will go in and know exactly what people want from day one. I don't buy that I just don't believe it's true. I think we're all learning, and it's very different in different countries, different markets. So you have to be very alert for where the opportunities are.
And if I was to come back here in, let's say, 2 years' time, where will Caldera be in your cycle there?
I hope the factory will be baking hot, because we're making blocks every single day, and it does get quite hot in here when we're running flat out. And I'd like to think we have a long pipeline, and also we're talking to companies in, let's say, regions we're not going to exploit ourselves, about how we scale the technology, because I do believe we have something really exceptional here that's different to sort of, let's say, we've positioned ourselves quite differently to, I think, our competitors, but I want to make a difference, and it's no good if we just have a European business when so much of the heat in the world is elsewhere, industrial heat.
Cleaning Up is proud to be supported by its leadership circle. The members are Actis, Alcazar Energy, Arup, Copenhagen Infrastructure Partners, Signum Capital, Davidson Kempner, Ecopragma Capital, EDP, Eurelectric, the Gilardini Foundation, KKR, Mitsubishi Heavy Industries, National Grid, Octopus Energy, Quadrature Climate Foundation, Schneider Electric, SDCL, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. To keep up with all that's going on in the Cleaning Up universe, make sure you subscribe to our newsletter. Written and edited by my longtime New Energy Finance and Bloomberg NEF colleague, Angus McCrone, it comes out every second Monday. Angus provides the latest on the episodes we're recording, the events we're hosting, stories we're watching, and what Bryony Worthington and I are up to. To sign up for the Cleaning Up newsletter, visit cleaningup.live.
You mentioned competitors just earlier. There are other medium through which you can store heat. I've heard of liquid sand, and there's molten salts, there's bricks. What made you decide it was molten aluminium with a bit of rock in it?
So if we talk about competitors, I think the first thing is that there's temperature range and there's duration. So we're not interested in high temperatures. I think it's extremely challenging. You end up needing air to move it around, and you end up with very big pipes, and it's actually much more complicated than people think, because they don't tend to think about the pipes and how you move the heat around. So we have a sort of focused temperature range. And then when I talk about it, there are people that want to store maybe 100 hours and starting to, a week's worth of energy. And then I come to the other end, this electric boiler, which just generates heat real time. We're very close to the electric boiler. And so where I think we're different is we have a very tight focus on our temperature range, and we're very focused on a lot of power in and a lot of power out of a small space. And that's why we use steam to get the heat out. It's you get very small pipes to get a huge amount of energy through. And that was also my experience before, which is when previous company, we used air to move the heat around, and the ducting cost almost as much as the stores. I mean,
But this is more about, but what about the medium? So what was it about the aluminium and rocks?
Oh, because it's simple, because we have no moving parts. We put electricity into the store. That's how we get the heat in. I don't have to have fans. I don't have to worry about stratification. And then we can squirt water in and we flash it to steam, which comes out. So, it's just a very, very simple system, but you need the conductivity of the aluminium. And so I think the thing is, if you're moving like molten salts, very well understood technology, but you really don't want to let them go solid. If you go solid, you've got a real problem in your system. There's nothing to go wrong.
And is corrosion an issue?
No, not at all.
No, I know not for you, but if you were comparing it to a molten salt,
I think it's correct. I think it's not. I think it's well understood. I actually think it's not an issue. You need to use the right steels, but that applies.
And the right welding, it turns out.
Right welding. But I think the bigger concern always is if somebody walks away from it, you need to drain it down so that you can't, the pipes don't.
And would you say the UK has a lead in this technology, and has anyone from China rung you up and said, can we buy 10 of your units?
My phone is ringing us off the hook every day. I think the UK has an advantage. I mean, we do have areas. I think Europe and the US broadly, we have many more companies in this space than China at the moment. But China can move unbelievably fast. And it's half of the world's industrial heat. So from our side, it's actually quite interesting in the longer run, because we want to, but it's probably a licensing play. I don't believe we would ever be able to compete in China as a foreign company.
No, I think the big challenge now is to construct really clever JVs where you can perhaps take advantage of their scalability, but hold on to some of the value of your IP. There's a art in doing this, I think, that's going to be perfected, or going to have to be perfected. It's on the roadmap, but probably 2-3 years from now. But also, I mean, here we are, I don't know, day what of the Hormuz crisis after the Iran debacle. And clearly gas prices have been very volatile. I'm guessing that you could probably sell this now, not on a decarbonisation agenda, but on a how to hedge against future price shocks, potentially. We noticed after the initial invasion of Ukraine that they got caught out. A lot of them ended up with, they might have 2 or 3 year electricity contracts, and they had to renegotiate at a bad time. It's very expensive. I had noticed it that sort of concern starting to go away, and having
latest crisis now with in the Gulf, people are like, we just don't want the uncertainty. And I think for years, there was a message which was renewables were, unreliable, uncertain, variable. And I now think it's really clear that oil and gas is not reliable. It can be it has some benefits, and I'm a big fan of the fact that you need it for certain times of year when it's not going to be windy, it's not going to be sunny. I don't personally believe seasonal storage is a thing that we should even be thinking about, because because we're not doing all the sensible stuff. But so we have power stations, we know that they're going to be periods when we need them, so it's really important. But it's certainly not, we're becoming apparent, unless you have it yourself, it's really not reliable, and it's not a good idea to build your economy on it.
Well, I mean, that's the pragmatism, isn't it? That I think, unfortunately, we got a bit over-focused on decarbonising the power sector, which for the last 10 to 15% of that challenge is going to be incredibly expensive. Instead of thinking, okay, our electricity system is largely clean now, most of the time, so why don't we work out how to then spread the cost of that across a wider base of customers and electrify as much as we can? And this is where your technology kind of is going to fit in, right?
And I like to, for those that remember night storage heaters, I like to say we're a giant night storage heater in a vacuum flask. But, if you go back historically, we built in the UK, 12 gigawatts of nuclear power, and we put almost as many night storage heaters into people's homes. So these were things that switched on with Economy 7 from, I think, 11 till 6, and they drew power from the grid, and they kept the demand up overnight. We only built 3 gigawatts of pumped hydro of storage. So we built 4 times as much flexible demand as we built storage. And they wouldn't have dreamt of building the electricity system with an inflexible generator without having something that was flexible to absorb the demand. Germany, exactly the same. You're talking about a system that was centrally planned. This was when we had the Central Electricity Board, and engineers were in charge. And then what happened? We privatised it all, and then the market was deciding. So, discuss. And it seems to me that there is a lack of. To me, there's genuine need. We know we're building flexible, the variable generation, so it's very predictable. We know when it's happening. We are not making high-level strategic decisions to make it very easy to use that flexibility. So I don't feel, and industrial heat's very interesting because it's so big that actually you don't need lots of sites to produce really quite a big amount of flexible demand. To me, we're not, by trying to find market solutions, we're sometimes just missing very pragmatic, we could have a gigawatt of flexible heat that you could cut off that is there, but the market rules currently make it more expensive, basically make it cheaper to throw the electricity away than to use it. And these people will pay money for it. One
of the real issues is that we've decided to do everything all at once, everywhere. And even the really, really hard things we're spending money on today, when you kind of know that there's a lot of low-hanging fruit that can be addressed, as, in this sector of easy to do, which we should be focused on. And then we don't always have to be the first people to do everything. There will be cascading technologies that emerge. If we get this grade of heat correct, maybe that'll teach us something about the harder to do things. I feel like if we will focus a bit more on the easy and cheap things, relatively cheap things, we'd make a lot more progress.
I think it's difficult because, certain things like hydrogen, they sound exciting, but it's just like a lot of the important stuff is boring, and we could do it really fast if we focused on it. I'm a new build homes. I just think they should be better insulated. It's an easy win. It's much easier to do it when you're building the home than going into an old property and refitting it. So to me, I think there are certain things we could do, and I think some of them are being done. But I also think I see a huge amount of not just resource, but mental energy spent on stuff that I think should be completely ignored. I'm like, if it's not going to work in the next 10 years, we should spend no time on it, because 10 years ago, you couldn't buy an electric car. And if you'd made forecasts 10 years ago on where we are now, you'd have been completely wrong, and you'd have wasted a whole lot of resource, actually, as was done.
Well, we did. We decided we were going to do bioethanol or whatever we did, thinking that was the future. But we've made mistakes in terms of trying to predict.
But I think there's a sort of pragmatic. Look, we're the pragmatic.
You're on the right
engineers.
show for pragmatism, absolutely.
And for us, there was So I also go into and this is a pragmatic point about hybridization. It's a journey where it's a transition. We're not fully decarbonized, and it's very hard to fully decarbonize a factory today affordably. In fact, it'll probably cost you a huge amount of money unless you've designed it from day one. So retrofitting. So we want to go into factories today and help them take 10, 20, 30, 40% off their carbon emissions, and we want them to save money. And you can make a business case. You try and take them to 100% in a lot of markets, it costs them an absolute fortune. But the point is, the 10, 20, 30, 40% then supports us building some more wind turbines and some more batteries. And we need to grow effectively demand, and particularly flexible demand, alongside generation.
I suppose we should just end with, we're in a reasonably political, turbulent time, to say the least. We've potentially got, new policies that might be developed in energy. There are a couple of things that if you had, an audience with the energy secretary, that you'd pick out for how could we scale this and keep this, and make this a British success story? I
would say recognizing the value of flexibility. So if somebody has a flexible asset they can turn off, don't charge them a fortune to have a grid connection. They're actually helping the system. They're helping to reduce the cost for everybody. And look at how we apply these fixed charges for, the renewable payments, because there are so many people we talk to that would use the electricity if those were effectively removed when you want people to consume it. And it ends up just being, it makes me sad because we do waste far more electricity than we need to for people that would use it.
You mean in terms of curtailment?
Yes.
Yeah. And one thing I've got some hope for, I think we've turned a corner now where at a European level and now at a British level, we are seeing electrification as the route to efficiency improvements and decarbonisation, rather than renewables obligations or energy efficiency obligations, which were separate. We've now, I think the penny's dropped that electrification is your efficiency measure and a decarbonisation measure. And we're starting to see targets set. So, I'm hopeful we'll get clear electrification goals. We'll ditch any stupid hydrogen strategy that's still lingering, and we'll just get focused on this because it's the efficiency improvement as well overall that's exciting.
I completely agree. I think most factories we talk to think if they're all electric, they've done what they need to, because everyone believes the electric system is going to become lower and lower carbon.
Well, it's already clean enough. I always think, for it to pay back, if you're thinking of moving to an electric car, you really only need it to be under 500 grams per kilowatt hour. And we're already at that. We're well below that. And so, electrify makes sense now. Yeah.
Agreed.
Great. And in fact, never been a better time to electrify given everything that's going on in the world.
It's actually really exciting. And it's so different from, I'd say 5 years ago. It feels like there is so much more interest in the sort of things that we do, because we've reached that point now where there's lots of surplus, and suddenly everyone's going, it is a problem. We do need to tackle it. But if you went back 5 years ago, that wasn't the case. So it is exciting.
Fantastic. Thank you, James.
Thank you very much, Bryony.
So that was James Macnaghten, founder and CEO of Caldera. My thanks as ever to Kendall Smith, our head of operations, to Oscar Boyd, our producer, to Jamie Oliver, our editor, and to the rest of the Cleaning Up team and the wonderful Leadership Circle members who make this podcast possible. And thanks to you for listening. Please join us at the same time next week for another episode of Cleaning Up.
Cleaning Up is proud to be supported by its Leadership Circle. The members are Actis, Alcazar Energy, Arup, Copenhagen Infrastructure Partners, Signum Capital, Davidson Kempner, Ecopragma Capital, EDP, Euroelectric, the Gilardini Foundation, KKR, Mitsubishi Heavy Industries, National Grid, Octopus Energy, Quadrature Climate Foundation, Schneider Electric, SDCL, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. If you're enjoying this episode, please hit like, leave a comment, and also recommend it to friends, family, colleagues, and absolutely everyone. To browse our archive of around 250 past episodes and to subscribe to our free newsletter, visit cleaningup.live.